Welcome to our first video on actual statistics. In this first lesson, we're just going to do a brief introduction to statistics, what it's about, and some basic vocabulary that we're going to use over the course of this first week. And pardon me, I have messy handwriting. I'm doing this on an iPad. I will do my best. So the first question is, what is statistics? Why are you taking this course? So statistics is all about data. So basically we're going to look at collecting data. Where does it data come from? Presenting data. How do I share that data with others? Summarizing data with summary values. And then the last two things is we're going to be analyzing data and drawing conclusions from data. I know how to spell conclusions. So stats really is all about data or information. How do we collect it? Where does it come from? How do I share it with others? How do I summarize and analyzing it in meaningful ways? And then how do I take that data that was collected from a limited number of people or items and expand that into conclusions about an entire group of people? The first thing you need to know is that when we collect data, data can come in two varieties. So I have some data, and I can either classify it as categorical data or quantitative data. And categorical is kind of what it sounds like. It has to do with categories. If you're asking people in a survey questions that require a word answer, that's probably categorical data. So for example, hair color is categorical. Shirt size, small, medium, large, X large, is categorical. Another one that's categorical but might not sound like it is student ID number. It's a number, it's not a category or a word, but it's a number I can't do math with. If I were to add up all of the student ID numbers and divide by the number of students, it's not going to give me any meaningful value. So sometimes numbers fall in the categorical side of data when they're numbers that don't have any real world meaning. Quantitative is numeric, strictly numeric. These guys are the numbers, and we can sort these numbers into two different groups. So quantitative or numeric data is either discrete quantitative data or continuous quantitative data. And the question is, what's the difference? Discrete data is countable. It comes from counting things. So example, number of books in a library, number of tickets sold for a show. Almost always discrete quantitative data starts with the description number of and then something. So discrete is countable. Continuous data typically comes from things that are being measured. I need a ruler, I need a scale, I need a stopwatch. So for example, height. Right, if I want the average height of students at Shasta College, height is a continuous quantitative value. Length of time standing in line would be continuous. I can have fractions in a second. Generally, discrete data is going to be whole numbers. I'm counting on my fingers, 1, 2, 3. Continuous can be fractions and decimals. Doesn't have to be, but can be. For example, if we are measuring height, I can be exactly 5'8", but I could also be 5'8.5", 5'8 2/3 of an inch. So it's possible to have whole numbers here, but I can also have fractions and decimals. This guy's always going to be whole numbers, because it's something that I'm counting on my fingers. The other thing I want to clarify before we jump into actually doing some stats is the difference between population and sample. And this is answering the question, where is the data coming from? So there are two possible answers. It's coming from the population, and the population is the group that we are interested in studying. If I am collecting data from the population of interest, meaning I'm actually able to give that survey to every single person at Shasta College, I would call that a census. And we'll see that word again later in another video. Typically, it is difficult to collect data from the population. Our populations are typically too large. If I am doing sociology on a large scale and I'm looking at the entire US, I can't talk to every single adult in the US. I don't have the time. I don't have the money to pay people to do that. That's not practical. So more often than not, our data is coming from a sample. And a sample is a smaller subsection of the population. Whoops, sorry about that. For example, if I'm studying behaviors of Shasta College students, there are a lot of you, and you're not all living in Reading. That's a difficult population to survey. So what I would do is I would make a list of all of the student IDs of currently enrolled students, and then I would use technology to randomly select 50 of those student ID numbers and interview those 50 students. So more often than not, our data is coming from a sample. If my data came from a population, the values that came from that population are called parameters. And you will notice that P goes with P. Again, we don't see that very often because it's difficult. More often we're looking at a sample, and values that I calculate from a sample are called statistics, which is where this course gets its name, and you'll notice S with S. Later in the course, we're going to learn about probability, which is a measure of how likely something is, and that's going to allow us to take sample statistics and draw conclusions about missing population parameters. So more often than not, what we're doing as statisticians is we're posing a research question, we're collecting a random sample from our population of interest, and then we're using probability to take those sample statistics and make reasonable conclusions about the population that that sample statistic came from. All right, so that's it for our first video. If you have any questions, reach out via email. Otherwise, I'll see you in our next video.